Sorry about that, I was just doing some quantum mechanics. My name is Cameron Flett, and I'm going to try and explain quantum computing to you. I'm going to try and break it down as easy as I can, but even for us researchers in the field, it can be very confusing. Werner Heisenberg, one of the grandfathers of quantum mechanics, said, "Not only is the universe stranger than we think, it's stranger than we can think." Quantum mechanics and the theories used for our current quantum computing originated around the 1900s. The first quantum computer came out in the 1990s, but really you haven't seen any size or scale that has made it usable until the last few years. Quantum is not a faster, more powerful computer, it's a completely different technology. Just like going from a candle to a light bulb isn't just the addition of a number of candles. Traditional computers work in binaries, so 1 or 2 states. Quantum computers use qubits that hold 1, a 0, or a superposition of the 2 values at once at differing percentages. Whereas 20 traditional bits can hold only 60 pieces of information, 20 qubits can hold up to 1 million different values at once. Additionally, quantum also deals with entanglement, whereas qubits of information can influence each other, whereas they can hold the same position at once and transfer information simultaneously. Unlike traditional computers that must complete computations in sequence in order to move forward, quantum are able to work with hundreds of inputs simultaneously, allowing much larger processing ability and completion of more complex problems, such as searching huge databases in a much smaller time frame. Quantum computing is hailed as the next progression in our ability to solve the world around us. It can reduce power usage of computing by up to 1,000 times. Whereas today the best computers can solve around 200 million equations per second, quantum would be up to 1 trillion per second or larger. Quantum could speed up what is taking AI years to do today, which can be done in seconds with quantum computing. It allows for the teleportation of information without traditional connections. Who would have thought Star Trek might have got it right? So is the time now, or is this science fiction? Einstein, when asked about quantum superposition, said that God does not play dice with the universe. But at the end of his career, he went back on his words and said that might have been the biggest mistake of his career. All large tech companies are investing. IBM, Google, Microsoft, universities and governments around the world are throwing huge amounts of money at this. The US recently announced a $1.2 billion investment, and China just announced a $10 billion quantum supercenter. IBM is declaring that within 2 to 5 years, they'll have full-scale commercialization of this technology, meaning everyday companies could use it as part of their cloud services. Whereas the industry thinks that within 5 to 10 years, the quantum advantage of quantum computing being better than any supercomputer in the world, where quantum will surpass all supercomputers globally. This shows that with the slowing of Moore's laws with traditional computers, whereas we're not seeing that doubling of computing power every year, this could be the new step for processing and problem solving. Therefore, it's my belief that the tipping point is here and you should get out and learn quantum programming or join your local quantum club.